next speaker is William, or known as Billy. Billy Sweet. He's an oceanographer with the National Ocean Service Center for Operational Oceanographic Products and Services, and really is one of our local sea level rise experts. And you'll hear a lot about how sea level is changing differently within the U.S. itself.
Great. Well, thank you. So, what I really am going to talk about today is taking what we've heard, this change in the mean, and really what does that mean to us living on land? There's a component that has not been discussed. It's called vertical land motion. We measure from tide gauges. In many areas around the country, land is actually sinking at the same rate that the ocean is rising. Together, it's a double whammy. Every 6 to 7 years on the East Coast, the relative change in sea level is 1 inch. Sea level rises relative to land by 1 inch. It doesn't seem like much, but now think a few decades. It starts to add up. So the title of the talk, Tide Gauges, Sea Level Rise, and Nuisance Flood Frequency Increases Around the U.S. Coast. A recent technical report we put out this summer touched upon this topic, and we can share that link with you so you can read more. So we'll talk about water level stations, tide gauges. Laurie introduced the ways we observe remotely and give you sort of an idea of globally what's going on. Tide gauges give you that local flavor. Not only sea level rise rates at your coast, which again can be subsidence, land subsidence due to glacial rebound, human activities, withdrawal of gas, water, oil that can actually cause land to sink, sediments to compact. They've been in operation for over a century at many places around our country. Our sentinels. They provide continuous water level observations at the land-sea boundary. We live on land, so again, we need to know what is going on right at that interface for local decision making. So what they've shown us is a steady rise in local mean sea level. As you saw, sea level rise is not uniform, it's not a bathtub, it changes. But it also changes by the rate that your land may be sinking. Some areas it's rebounding. Alaska, you actually have sea level that's dropping because the glaciers are no longer there, they're retreating, and land's actually coming up out of the mantle. They don't have a sea level rise problem, they have a sea level drop issue. Maybe you were oceanfront, now you're pretty far away. Okay, that's probably not too much of a worry compared to places down in the Gulf, the mid-Atlantic, Chesapeake area where sea level is actually rising fairly rapidly due to this large land subsidence piece. So they give us these long-term rates of relative sea level rise. And you've heard sort of why globally things are changing. Again, I would add this other non-climatic piece. Nonetheless, it's a change that has consequences. So we have been running these tide gauges for, like I said, over a century. It's called the National Water Level Observation Network. Traditionally, it was installed to help safe shipping, high tide, low tide. It delineates public-private boundaries, economic zones, real-time observations, tide predictions. All of you have been to the coast, high tide, low tide. I'm going to go fish at high tide, low tide. It's sort of inherent to our understanding of the ocean when we're there, and it's just something we use for like the weather. Long-term delineation or these datums, okay, mean low or low water. Well, if you're a mariner or if you sail, you might want to know that that reading on your chart really is indicative. At the lowest point of that tide, you're not going to run aground, right? If it says you have 5 feet of water and you draw 5 feet of water, all of a sudden it's 4 feet and you say, well, what's going on? So it gives you sort of this conservative estimate. Mean high water, okay, average sort of the highest daily tide. The rack lines on the beach, they sort of vary, a meter or so. Sometimes you have a storm, sure, low tide, but in general it sort of defines where the high tides tend to be and where the low tides. Mean sea level is a little bit more nebulous, sort of esoteric. What does a change in mean sea level mean to you? Well, could you go to the beach and show me where mean sea level is? Well, it's sort of telling you where this overall, the average of all of your water level observations, where is it? And so as that mean rises, so too do your other, your high and low tides. We'll get into that. Very important to stress is this benchmark network. So we actually have, if anyone surveys or shoots in footers for buildings, connect with a brother-in-law as a developer in Raleigh. He loves Fox News, and that's great. He watches news. Though the whole idea of sea level rise, I can sort of navigate carefully around the political divides and say, well, listen, Shaw, Every year we go and do level 2 surveying with these precise surveying equipment. You understand that, he understands this. It's a continuous observation, and we want to take these datums that tell you what's going on with the land, and we want to put these long-term average, 19-year average would be mean sea level or mean high water, a high tide line. So if you're at a coast, you want to say, well, how high are you above the tide? You can go to a benchmark and we can give you this conversion, and it's based upon just surveying techniques. So it's pretty unbiased, let's say. So our situation is that we have a current frame of reference looking down, and I say the clock's ticking, and we'll get into that. We heavily built in the 30s, 40s, 50s, 60s, sort of out of the range of the typical high tide. And your storms. Sure, there was that infrequent rare event that would come in and oftentimes is devastating. It takes lives and destroys livelihoods, but for the most part, we take our licks, we rebuild. But we tend to stay sort of within a certain region above high tide. So in today's world of changing sea levels, I think it's important for us to start thinking in terms of some concern datum, some elevation above high tide that your system has a tolerance to. Let's say you're a bridge, you have a clearance. As the water rises, ships get bigger. You don't want to take out your bridge just for the fact that sea level's gone up. The other areas, let's say stormwater systems. A lot of areas that I'll talk about coming up are seeing that gravity fed. You're at the coast, it rains, it goes into the sewers, gutters, stormwater flows into a receiving body. Now that receiving body is a lot higher than it was when it was built, and there is no downhill gradient to get water off the streets. Active pump systems first changed due to sea level rise. Miami, Charleston, Norfolk, these areas are really saying of a hydraulic mandate to get the water off the streets. We're getting a lot of sunny day flooding. We'll talk about that. Wastewater treatment systems. Well, there's Sandy, of course, the subway with water in it. Well, that exceeded some threshold and you flooded your subways. Every system has sort of a different tolerance, a different elevation, magnitude, frequency, intensity. So how do we experience sea level? If I take 1 year of data from a tide gauge, high tide, low tide, it sort of makes a bell-shaped curve. But we don't experience the mean, we experience the events. And when we really look at these events, so here's sort of the green being a high tide line. Well, we experience maybe a storm. And I'll get to these National Weather Service. The NWS stands for minor, moderate, major. These are local flood impact levels. It gets to this elevation, certain impacts become seen. So I think that what's here to note is that there is an area between, let's say, mean high water and a typical amount of some storm that might cause minor or moderate flooding. That one step and run, if sea level increases by 1 step, the response in the run is not equal sort of linear rise. It starts becoming very rapidly transitioning. Okay, so what this means is as sea level rises, the impacts that you expect that happen today are more severe than yesterday, maybe a few years ago, and going to be much more severe in the near future under even the same rate of sea level rise.
Why is that?
Well, that is because there's if you take, and I'll actually get to that, but essentially there's an operating space. Think of rack lines on the beach, okay? High tide to low tide. 365 days a year, you're somewhere in between the two, okay? As that rack line moves up, let's say now it's starting to get up to the top of the dunes, or in cities, maybe that means water starting to come out of the sewers. It only usually operates between maybe a 1 meter, 2 meter operating room, operating space. The larger events are very infrequent. The smaller the events, maybe a big high tide, a minor storm, they become more frequent in nature. Things that are less severe tend to happen more often. The things that are most severe happen less often. And so as this whole bell shape sort of rises up, you now get into relative to a fixed elevation where we live. As something used to just happen during a very large event, maybe 50 years ago, sea level was larger, a lot lower. It took a very large event to cause that problem. Now sea level's higher, much minor events are starting to cause those same sort of problems, and the minor events are much more frequent than the large events.
Can you explain what the y-axis is?
So the y-axis would be the number of hours. So if we sum all this up, there'd be 8,760 hours in a year. And so it's saying the number of hours spent at or above this elevation. So the water level here would be mean sea level. Again, where's mean sea level? We might know what the mean high tide is. So how many hours are you above sort of a high tide situation? And this is actually an example from Norfolk. And I'll give another or two illustrations of this principle, and it might make it a bit more clear.
But so the hurricane resulted in almost 300 hours of variation?
No, so if you look at, let's say, Sandy, if I come over here to the line, it might have been 1 or 2 hours. So this is elevation on the x-axis.
So that's just showing a point. Those are not like
yeah,
actual,
this would be the numbers of hours spent above some elevation. So if you go to the elevation and say 2 meters above high tide, that's a major storm. Maybe that didn't even happen this year, but maybe at the very peak high tide, maybe it spent 1 hour. But again, those are very infrequent. Maybe they happen once every 10 years. And I'll get back to this principle. So we've sort of set up shop around the country about 1 to 2 feet above high tide. That's where our infrastructure is. This nuisance flooding, okay, I haven't talked about it yet, is this concept of localized, minor, tidally driven, and recurrent flooding that we're starting to see more of. 1 to 2 feet above high tide. When water levels exceed that, local impacts are starting to become noticed. So what does it look like? It might be overtopping sort of a walkway. This might be a little bit higher than minor per se, but it counts nonetheless. It's sort of having fun, not very funny situation. She seems to be fairly well adapted to the situation here in Miami. Probably have some rusty rotors here in Charleston. Some of this might have occurred with rainfall, but again, if you can't clear the water off your streets because higher tides have resulted in an ineffective stormwater system, you have a problem. This is probably typically what you'd see Eagle Alley in Annapolis. I sail there a lot. Water is about to spill over into the parking lot. It's already coming up through the sewer. Just not much freeboard left. Stormwater systems that now are basically the outlets are practically underwater. The big king tide in October, I don't know if you caught wind of this in the news, maybe somebody reported on it. A lot of dignitaries and senators were headed down to see the flooding. And a colleague was flying around in a helicopter with one of the senators, and they found some. Just king tide, so these are typical high tide events during the year. Some pretty expensive real estate, I can imagine. Asked Obey, how many times a year did you have sunny day flooding before they started installing pump systems? And it was loosely a handful of times a year when it was time to get the water off the streets. Very expensive system now they have installed and are still building.
Was that in Florida?
That was in Florida, South Florida. Annapolis, just a month ago or so, high water. So these events, the National Weather Service has established these elevations around the country. Years of impact monitoring. After a big event or a small event, they go back and look at our tide gauges and see what exactly was the elevation on our tide gauge. Jones Street's flooding again. Seawall seems to be overtopping. The sort of the stories, and they would rate them. Was it minor or nuisance, is what I called it? Is it moderate or was it major? And they're locally specific. They have the flavor of that town. Maybe you've already installed a giant seawall, Galveston, so your nuisance flooding now really requires a lot more water than, let's say, an area that's a little bit under-defended, let's say. So I simply use these numbers at our local tide gauges that have them. And whenever a water level, the blue would be what's predicted. We can tell you when high tide's going to be. Water level might be a little higher. There might have been a storm. Whenever the water level observation crosses some threshold that's been established, I make it count. And say, well, how many times? And I can look back in history now and say, how's this been changing in frequency? And so I guess sort of Bob Dylan, his B-side hit was the tides they are changing. As relative sea level rise is increasing due to land subsidence and local realization of that global rise, your high tides are just getting higher. Your minor storms are becoming more impacting relative to our fixed elevation, our development infrastructure that we have in place. And so when we look at sea level rise, what are the impacts of sea level rise on nuisance flooding, for instance, that we can measure? Well, it increases the mean. A little bit esoteric. What does mean sea level rise mean to you? Well, It's the tides and the storms you tend to think about. Sure, it can change the probabilities of these very extreme events, but the problem is they're just not recurrent enough for us to start making comparisons. We haven't had 10 Sandys that we say, those sandy events are just getting really that much stronger. They're very rare. We know that, yes, now they're becoming more destructive. But it's probably not the time and place necessarily to be talking about climate change impacts to the people looking at the destruction in their town. But the opportunity that really presents itself are these recurrent events that are becoming more noticeable, very repetitive. People can start to say, I've been here for 6 decades. I've lived here all my life, and I've really seen a big difference, big change. There's not too many of those folks in that true testament there in these communities to really to marry our observations. When we hear the stories from them, that's great. The tide gauges are there, and they're telling us that the frequency is changing. So I would say that's the more intuitive indicator of climate change-related sea level rise, of these recurrent flooding events. So this will sort of get back to the other bell-shaped curve I showed. So if I look at 1 year of data from, let's say this is Norfolk. Okay, so here's mean sea level. Green is sort of your high tide average. Yellow would be your nuisance flood elevation. And this is 1950. So your daily maximum is sort of within this area of around mean high relative today. This is today's elevations. Okay, 1950, I'm on the same apples to apples. But when I go to 1912, look, everything's just shifted up. Sure, you have a large storm. That was actually NOAA. Okay. You have some large storms occasionally, but you also have these typical events that are now just getting closer and closer to this nuisance flood level. Daily maximums now have shifted up too, so I'm starting to look at these daily highest events. And so this concept is, again, this bell shape, okay? So everything underneath this bell shape would be equal if I'm looking at daily maximums, 365 days a year. If I look at all your highest tides in each day, how do they distribute? Well, there are a lot of mediocre ones or less larger ones, but this curve is being shifted forward in time, crossing this nuisance level more often. And I'm also in this area of a rapid transition zone. A few more increments of sea level rise, and you don't just have a small increment change in sea level impacts. And we'll show that. So maybe put it this way. Maybe that bell-shaped curve makes more sense when it starts exceeding. It actually is blue, and it means it's wet. But when I look at the number of times per year with minor nuisance flooding, that is not a smooth linear trend. That's an accelerating impact trend associated with more of a linear steady sea level rise. We're already entering these transition zones in many cities around the country. And we're going to stay on this slide for a moment. It's a powerful message. Okay, well, there we are. Okay, so I'll give you a quick example. Atlantic City, same sort of thing. The blue would be sea level rise since 1920. It's on this other axis. So sea level there, I don't know what happened to the label there. That would be in meters. So it's changed by about a foot, maybe a third of a meter or so over that time period. But you can see the number of hours spent above the minor threshold, or the number of days with nuisance has been by no means a linear small adjustment. The lower right-hand plot is, again, similar to the plot you just saw, and in this case in Atlantic City, it would be the yellow bar is now plotted as dots, numbers per year. It's just we're on this accelerating trajectory. What's next year going to hold in terms of these events? And at what point do you get where you need to start mitigating for this? It's just not one or two places, and here I give a quick snapshot of the Mid-Atlantic, Boston, Norfolk, number of years with exceeding their local nuisance level. You can see it's a very common feature, and in fact, it's a feature common around the United States and the world. I only looked at the United States. And so it's an emerging coastal flooding crisis. And we had a report out. There's a link. This was on our website. It's actually a climate toolkit that sort of talks about nuisance flooding, what it is, how it happens, what are some underlying causes. And we also give some rate increases over the last several decades in terms of what that actual elevation is defined by the Weather Service locally, and what is some of the numbers and how they've been increasing in terms of time. And so I'll close on this last slide. Is there a tipping point? So at what point does a community say, you know, we're experiencing too many of these events, I need to go ahead and start making some public work adjustments, mitigation. First up, maybe stormwater systems. Hampton, Sydney, Norfolk, dealing with this right now. We don't want to piecemeal our approach. Let's look at this citywide. Like I said, Miami, Charleston, there's many municipalities already actively putting in stormwater systems active that take the water and get them off the streets. Tens, hundreds of millions of dollars. One piece of infrastructure. So this nuisance flood level, again, this mean high water, I guess I would say, well, maybe it's much less sea level rise and happening much sooner than sea level rise projections discussed by 2100. Maybe sea level rise 2 feet, maybe 3 feet by 2100. You know what? The impacts are going to be felt much before that. Maybe we only need about a quarter meter, less than a foot, such that now we have 30 to 40 of these events per year in this area. That might be sufficient to really cause change and maybe a costly adaptation. And I'll say that we're actually going to have a paper released later this week discussing that concept and use in the latest IPCC, which was mentioned, projections, so that we can start giving some time horizons for this tipping point. 30 days a year, but you know it's going to be a local condition, but it's a starting point for the conversation nationally. Thank you.
So if there are any particular questions just related to sea level rise, since we just saw the two presentations on that, I'll take a couple now and then we'll do the free presentation. Then if you have specific questions after that, we can do that. But first, sea level. Yeah.
You mentioned Great Lakes earlier. I'm curious, does any of this impact freshwater flooding or like freshwater impacts, or are they completely separate?
Yeah, okay. The Great Lakes, sorry, I thought for a minute it was directed at Laurie.
No, I mean, like earlier you had just mentioned that you guys do work with the Great Lakes, but I'm just curious, you know, like I grew up in St. Louis, so I'm very familiar with Mississippi flooding, and I'm just curious how, if at all, sea level rise and coastal flooding plays with freshwater flooding, or if they're completely separate phenomena.
Well, that would be a separate phenomenon in that, again, the Great Lakes are pretty much insular from the actual ocean, so they're not experiencing this systemic trend or this gradual increase in volume. They're very much more driven by hydrologic runoff and usage, and there's been actually the Great Lakes were quite low for some time, and their variability fluctuation is driven by other processes. But when you look at, we have 50 or so tide gauges there for shipping reasons. When you look at long-term trends, there are long-term records. There are no increases, long-term trend increases in volume. It's all very much ups and downs over years to decades. So it's more of a freshwater delivery issue.
And I will say, NOAA actually recently released a tool we have a Great Lakes Environmental Research Lab in Ann Arbor, Michigan, and they actually have a cool new tool where you can look at water levels within each of the Great Lakes and trends over time. And it's its own dynamic with the Great Lakes related to amount of ice cover, amount of evaporation, as well as what's draining into the watershed throughout the year. So it's that net in and out of the Great Lakes. And there are, you know, longer term precipitation trends that you're starting to see show up in the Great Lakes too. Yep.
Is the ice melting because the ocean is warming, or is there something else going on?
The phenomenon that was written up in the Post is largely related to the fact that the ocean that is reaching underneath the ice shelves in the Antarctic is actually warming, and so it is warmer than it was, and it's causing the ice shelves to loosen and start calving. So it is largely a direct impact of the fact that the oceans are warmer. The same phenomenon is going on in Greenland, in some of the fjords in Greenland, and there's a fairly large international experiment that's going to be studying that. There are other effects that are going on in terms of the fact that the atmosphere is warmer and it's causing melting of the surface of Greenland, but it's not having as large of an impact, which then runs off. But that's not having as large of an impact as this whole phenomenon of the ocean, the warm oceans undercutting the glaciers at their coastal heads.
And then is that also the same in the Arctic where you have ice floating on the ocean? So
Well, another big story, obviously, is the loss of sea ice in the Arctic, which is screwing everything up. And that is also partly related to, well, that's warming in the atmosphere and also the ocean. So it's a combined effect.
we'll go there first.
I'm from Uganda, and we depend on the River Nile for electricity generation. But a few years ago, we started having power rationing because supposedly the water levels in the Nile were dropping and not enough to run the turbines. That's my understanding. That seemed to be contradictory with the sea levels rising. Is there any relation? Is the water all draining to the sea? I mean, how is that?
It all eventually drains to the sea unless it's stopped by dams. I think that's probably more of your rainfall patterns that were inherent to some of the graphics that Laurie showed in terms of year-to-year variability of where a lot of your rain is occurring and not occurring, and there is a El Nino, La Nina signature, so there are instances, let's say during strong La Nina, you tend to get more rain on certain land masses, maybe not necessarily the African, I'm not exactly sure of the impact there, but that's probably more due to climate-related variability within rainfall pattern. The ocean there wouldn't really be entering upstream.
So the Nile flows into the Mediterranean Sea?
Yeah.
I mean, so no relation?
I think where Uganda is, it's all freshwater. There's no tidal connection. I mean, the Nile, where it meets, is in Egypt, and so I think Uganda, it's really a freshwater system. So it's dependent on how much rainfall is running onto the land and then draining, and what is being intercepted before it reaches the lake. But also, if there is a turbine issue, sometimes there are problems with sediments that, when you dam a river, it basically causes the sediments to fall out. And so over time, you get the basin fills up with sediments, and it creates kind of inefficiencies in how they can generate hydroelectricity. And that happens around the world. So but it's not really an ocean connection, I think, in the case of Uganda, since it's pretty much in the middle of Africa.
The GRACE satellite system that we discussed just briefly, it not only measures the gravity variations over the ocean, it measures gravity variations everywhere. And one of the prime uses of the data is studying changes in the groundwater of regions like India, parts of Africa, central California, which is depleting water. There's a whole series of articles that were based on GRACE data. You might want to look at the NASA website because there's some fascinating work being done with that.
Question in the back.
Yeah, so I'm curious to hear, I do a lot of reporting on communities that are burying their heads in the sand about this, but what I would be interested to know, are there communities that are reaching out to you guys saying, do they exist, saying, please give us more information on sea level rise, we want to actively work on this? Are there standouts as opposed to the ones that I give a hard time?
Yeah.
Yeah,
Bill.
there are. For instance, an example right now would be in the Hampton Road area of Norfolk, that they're really asking for all of government to really come in and see if they can work together to deliver some critical information there. I think they're rated as the second most vulnerable community to sea level rise after New Orleans, which we know already has a large defensive structure in place to prevent the type of flooding, and due to the large naval presence. So there are communities that definitely ask for the information, and we, where we have our observation programs or information, we will try to customize and develop the products and services that they ask for, that our data might support. So the Army Corps of Engineers, Department of Defense, or other agencies that we work closely within NOAA to help sort of transfer the meaning of the observations into actionable information for them to make decisions.
How does New York City fall in that spectrum?
Well, New York City, I guess after the Sandy recovery, there was quite a bit of activity there within quite a few different groups within NOAA, the USGS, FEMA, said let's revisit this, let's remap it, see what's changed, but also let's start looking at how, in terms of probabilities of these large events, 100-year events, maybe we should relook at some of the FEMA floodplain mapping, and consider sea level rise. So I think it really brought to the attention that we need to get a good understanding of what the probability of having these types of events are and how that might change in the future. I think that really helped that propel that discussion.
The state of California was very aggressive in trying to put together a plan. Forgive me, I haven't read it, but I know that they were very aggressive in terms of drawing together as much information as many people as possible. I don't know how that compares to other states, but there are certain states that are being very proactive about it. And the island nations of the far western Pacific their representatives are reaching out to both the U.S. and also primarily to Australia for help and information.
And NOAA does have a website called the Digital Coast, which consolidates a lot of our coastal information. And with on there, you can link to a lot of different city and county and state adaptation plans, of which NOAA has a lot of them use our sea level rise data and do work on various communities, trying to help them plan for future sea level rise and what, a 1, 2, 3, 4 level, using models and things, what that would look like in their community and where is their infrastructure, so things like hospitals, roads, utilities, power plants, nuclear power plants, what's subject to flooding in the future or, given different time frames. So that's a really active part of local planning efforts, from regional efforts to states down to local communities and cities. Yep.
Does all this mean that our kids and grandkids' relationship with the ocean will fundamentally change? Instead of a place where we go to relax, it's this thing that's invading their lives. I mean, those pictures are scary.
Thursday we'll have the release of this new report that I think could lend some insight into potentially the time frame under the most current projections of sea level based upon these representative concentration pathways is what is discussed about what might emission scenarios look like. Are we really just going to stay within 2 degrees C warming by 2100? Are we going to come together as a world and really slow down and then reverse this trend? Or are we going to have more of the business as usual kind of emissions and the related sea level rise that comes along with it, with possibly projections that really still don't fundamentally understand quite the role of some of these large ice masses, but talking about 1.5 to 4 feet possibly within 2100 time frame, and I think there will be sort of a wake-up call that I think really should be heeded by younger generations because it will probably translate into expenditures.
To follow up, do you think reversing the trend is possible, or this big UN climate report that came out I think earlier this year said adaptability is where we should be focusing?
In terms of these representative concentration pathways of emissions, the sea level rise is still sort of there. There's a certain amount of commitment in terms of heat already in the ocean and responses that will occur. I think we can definitely help mitigate the potential response of the ocean, maybe try to stay down around the foot and a half. And again, this doesn't really take into consideration any vertical land motion that might be playing a major role in some of these towns, which is sort of a concept that you're not going to reverse necessarily. So I think there are ways that some solutions that are possibly there, but again, as you know, just as well as I, reading the news in terms of people making concerted decisions and saying we're really going to do something about it, it's very difficult to get this day and age, it seems. So.
I just use the latest projections and show what the response might be.
I'd just like to mention that, you know, in some sense, when we're talking about it in terms of the U.S., leaving aside horrible disasters where people die, what we're facing is a problem that is essentially an economic problem in some sense. Whereas places like Bangladesh and the South Pacific Islands, they're going to get wiped out. And that's going to mean, in the context of Bangladesh, hundreds of millions of people are going to be displaced. So there's a real danger of not paying attention to this.
Yep.
I have more of a media related question. So if when there is a huge breaking weather event, a storm, a hurricane, what's the best way to get someone to talk to you from your agency who's an expert when all of these news organizations, I'm sure, bombarding you trying to get an interview, a phoner,
Yep.
someone to give you a quote? Like, what do you recommend?
It's a great question, and we do have, so within NOAA, I work with the Office of Communications. We have my counterparts that are embedded in each of those line offices. So within our National Weather Service, we have we have 3 people currently, about to be 4 people, just 2 buildings over. They coordinate media inquiries for weather-related stuff, and they tap into, we have 122 forecast offices around the country, 7 river forecast centers, and our National Hurricane Center, our National Tsunami Warning Centers. So if it's a tsunami, a hurricane, a blizzard, a weather event, a flood, a heat wave, we can tap into that. If it's more climatey, like long-term climate, it would probably go to one of our more of our climate centers, either in Boulder or Asheville. If it's a sea level or ocean thing, it would Keeley right there works for our National Ocean Service. So we do have public affairs officers scattered throughout the agency. And I guess I would Google NOAA, Office of Communications, up will pop, if it's a fisheries question, you can see who our public affairs officers are for fisheries or for oceans or weather or satellites. And I do kind of more climate-y stuff.